Then when you go off on the siding, this will just pull cable out behind it. This is like an electric train with a big long extension cord. And when you want to come back, you would flip up a switch on the console there. That engages the motor and gearing here. And this reel will wind the cable back up at the right speed. And it's a very smart reel. It's keyed into the train, so the faster you go, the faster it goes. You slow down or stop, it does that. And it's better than that. The thing it sets on here detects load. It knows how heavy this reel is, so the rotation speed also changes to adjust to this changing diameter. It speeds up as you reel cable.
Pretty creative back in the day. So what was this one here then? Just a total of that.
mines here occupy an area about 7 miles wide and 40 miles long. They are entered through 20 or more vertical shafts. Most of them are connected below the surface by a network of rails. From the bottom of the shaft, miners have tunneled for ore miles upon miles in every direction. The wide areas where lead-bearing rock was mined are called stopes. The narrow corridors are the drifts that lead to the next stope. Many stopes now being mined are several miles from the shaft. Ore-bearing rock is drilled and blasted. Broken rock is then loaded and hauled back through the shaft, where it is hoisted to the mill on the surface. Level, 400 feet or more below the surface. Underground, drifts blasted out of solid rock, barren rock, open paths to new bodies of ore. Years ago, mules hauled broken rock through these passages. But the mules gave way to electric frames that haul tons instead of pounds, that make the haul in minutes instead of hours. More than 300 miles of rails and electric trolley lines spread out in every direction, hundreds of feet below the surface. Large openings are mined out areas. How much lead came out of these great stopes, no one knows. For these lead mines, the oldest in the United States, have been worked almost continuously for over 100 years. Unlike most other mines, there is no timbering. From the very beginning, the room and pillar method has been used. The tons of rock above are supported by great pillars. Occurs as a mineral called galena, a sulfide of lead which is disseminated through limestone. Galena contains about 80% lead. After the holes are drilled, they are loaded with dynamite and blasted. After blasting, when the air is clear of dust and powder fumes, loading begins. It takes $40,000 to $50,000 worth of equipment to put one man to work in these lead mines today. Machines designed to take the load off the man and to make every minute and every move more productive. Machinery takes the full burden of moving rock. The ore is moved forward by conveyor until the car is fully loaded. One man and a machine move 13 tons of rock in one load. The same man and the same machine can unload the rock in 30 seconds into mine cars for the long haul to the hoisting shaft. En route, ore is weighed automatically in the cars. Without uncoupling the cars, ore is emptied into a storage pocket to be hoisted to the surface. The cycle of drilling, breaking, loading, hauling, and hoisting is completed, and the ore is on its way to the mill. This is how the game is being won for lead. Men and equipment producing hundreds of tons of ore every hour. The mill team takes over the minute that ore sees table. Their job is to extract every possible ounce of galena from the ore, concentrate it, and make it ready for the smelter. Ore from the mines is fed to several giant crushers. Crushed and broken ore passes over screens, where the oversized pieces are turned back for further grinding in the rock mills. The action of the rods tumbling and rolling over the ore finally reduces it to a sand-like texture. The trick is to get the galena, or lead, separated from the sand. Very interesting one to watch. In gravity separation, the force of running water and the shaking motion of a table separate the ground ore into three products. One, galena, ready to be filtered and smelted. Two, middlings, sand still containing some galena which must be reprocessed. And three, tailings, sand free of galena, which is pumped out of the mill and allowed to dry. This crushed rock is a high-grade agricultural limestone containing essential plant nutrients. It is used extensively in farming areas for crop improvement. In the flotation process, the laws of gravity are seemingly defied. The fine-sized material is treated so that galena, the lead-bearing mineral, floats to the surface, while the sands, which are lighter, drop to the bottom. Why does galena, much heavier than sand, rise to the top, while the lighter rock and sand sink? Is this physics upside down? The answer lies in a carefully controlled combination of chemical reagents. Some are attracted to galena, but not the lighter sand. Other reagents assist air which has been forced into the flotation machines in making bubbles. Here is what actually happens within the tank. Sodium cyanide, a chemical attracted to zinc and iron sulfides, but not to lead sulfides, coats the zinc and iron crystals. Now a complex chemical compound known as xanthate is added. Xanthate is attracted to any sulfide mineral surface and also to air. But because the zinc and iron crystals are coated with sodium cyanide, the xanthate avoids them and is attracted only to the lead sulfide. The xanthate attracts an air bubble from air forced into the bottom of the tank. This air bubble also becomes attached to the lead particle and lifts it up into the froth made by a reagent such as creosote. The froth overflows, carrying the lead particle with it. Multiply this process millions of times, and that's what goes on in the flotation tanks. After the flotation, lead concentrate has been thickened. It is filtered. After drying, it is loaded for shipment to the smelter. That then is the work of the mill. But the difference between winning or losing the game in the mill lies with the men. Men with know-how and equipment, who are able to extract every possible pound of usable lead concentrate from the ore. Men with the watchfulness, the patience, and the skill that makes it possible to ensure the greatest return from the work begun so well in the mine.